Hello everyone, let's start working on some problems from this section 12.4 between number 1 to number 6. Let's choose to do number 4 and number 6. Starting with number 4, vector A, B, I, J, K. So the I is 0, 1 for J, 7 for K. The B is 2, -1, 4. So the cross product will be for the I position, we will do the determinant for this 4 minus -7, that's 11, right? Oh. And then for the J position, actually, if you think about it, it's basically this thing and this thing, right? So 0 minus 14, that's -14, but I changed the sign becomes positive 14. Now, to give you some other perspective, we can actually see it in the following way. Imagine if I copy this first column here, and then I do the determinant for this. You see 14 also, right? And then for the kth position, will be 0 minus 2, so that's -2. And then verify that it is orthogonal to both A and B. So what I will need to do is to show that A cross B dot A will give us 0. Okay, the first position is 0, the second position is 14, the third position is -14, that's 0, right? And then A cross B dot B, the first position is 22, the second position -14, the third position -8. It's also 0. So yes, the cross product of A and B is normal or orthogonal to A and also to B. Okay, now let's see number 6. Number 6. Oh, we have a vector function here. Instead of just a regular factor, now we have vector function t cosine t sine t, and then 1 negative sine t cosine t. Do you notice that b is actually the derivative with respect to t of vector A? Nice to know, huh? Okay, so A cross B will be what's that? A cross B will be this part here. Cosine squared plus sine squared. That's 1, huh? Let me write it down first. That's cosine squared t plus sine squared t. And then for the second position, t cosine t minus sine t. So that will be sine t minus t cosine t. And then the third position, the z component, that's negative t sine t negative t sine t minus cosine t. Okay, if I clean it up, then I will get one, you know what, a bit smaller and put it here. This will be 1 sine t minus t cosine t, negative t sine t minus cosine t. Now we need to check A cross B is perpendicular to A. I will just do one of them, okay? I will not do both of them. But it's basically, we need to show that the dot product of these two factors equals to 0. Okay, so A cross B times the first component will be T. The second component, this guy times this guy, is plus sine T cosine T minus T cosine square T. And for the third position, we need to do this guy with this guy, which is minus T sine square T minus sine T cosine T. Notice that this guys cancels. Let me mark it in. This guy here and this guy here cancels, right? Okay, and we have T minus, I will factor the T out. I get cosine square T plus sine square T, which is R1, right? So we have shown that the cross product of two factors must be perpendicular to those two factors. Okay, number 14. Okay, let's see the next question, number 14. Number 14. The question is, find magnitude of U cross phi and determine if the U cross phi is directed to the page, into the page, or out of the page. So let's see the magnitude first. This is equal to the magnitude of U times the magnitude of phi times sine of 45 degrees, the included angles, right? Notice that when we say included angles, it has to be initial point with initial point. Okay, and then we do the cross product in this direction, right? So because it is in that direction counterclockwise, then it will be jumping out of the page. Now going back to that magnitude of the cross product, magnitude of U is 4, magnitude of V is 5, sine 45 degrees is square root of 2 over 2. So that's 10 square root of 2. Okay, now question number 15, it's actually very similar, except that notice that the terminal point, the initial point are not met, right? So instead of like seeing the angle as 120 degrees, we copy this factor here and then move it this way. Okay, so the supposed look is this. Okay, and then you see that if this is factor U, this is factor V, it's actually clockwise. So the direction of the cross product will be into the paper, into the page. Okay, the angle is 60 degrees, and then you compute it yourself there. Okay, it's just like we cannot do the cross product if we don't have the included angle, And the angle you saw there is not the included angles. This 120 degrees here is not the included angles. Okay, that's for number 14 and 15. Let's see the next one. Let me move this up. Number 20, find two unit factors orthogonal to both j minus k and I plus j. We have this question actually in 12.3. At that time, we didn't have cross product. Now we have cross product, so it's easier to work with. Okay, let's call this u, factor u, be the resulting factor equals to the cross product I, j, k, and then j minus k is 0, 1, negative 1, I plus j is 1, 1, 0. So the cross product is 1, negative 1, negative 1, whose length is radical 3. Okay, so the unit factor we are looking for, one of them is 1 over radical 3, negative 1 over radical 3, negative 1 over radical 3. Okay, or if we simplify rationalize the denominator, square root of 3 over 3, negative square root of 3 over 3, negative square root of 3 over 3. Oh, they asked for two unit factors. What is the other one? Well, the other one is the opposite of that. Okay, the other one is the opposite of that. Okay, and you find out yourself what's that. Number 28. Find the area of parallelogram with these vertices. Okay, let's kind of like identify that first, sketch that first. So let's say this is vector k, and this is L, this is M, and this is N, right? The area of the parallelogram is equals to the magnitude of cross product of factor, let's say we use KL and KN. Okay, now let's see, KL is what? Factor KL is 1 minus 1, 0, 3 minus 2 is 1, 6 minus 3 is 3. While KN will be 3 minus 1 is 2, 7 minus 2 is 5, 3 minus 3 is 0. Okay, so the cross product will be, let's do the cross product first. Cross product is I, J, K with factor notation 0, 1, 3, 2, 5, 0. That will give us negative 15, positive 6, negative 2. Now let's compute the magnitude. So the magnitude is square root of negative 15 squared. I think that's 225 plus 6 squared is 36. Negative 2 squared is positive 4. Plus 47. That's square root of 265. Now this is also the area of parallelogram. Okay, now you may wonder, Thomas, how do we know we use factor KL and KN? Actually, you don't have to use these two here. The idea is you just don't want to choose two factors that are parallel. So you don't use this KL and MN, for example, or KN and LM. Because they are parallel, doing the cross product, you basically get they're parallel, right? They don't give us the area of parallelogram. What you need is actually just two consecutive sides of the parallelogram. Okay, so in this case, I use KL and LM, but you will see factor LM is parallel to factor KN. Okay, that's for number 28. Let's go on further. Find a non-zero factor orthogonal to the plane through the points PQR and find the area of triangle PQR. So let's choose to do which one. I will just do one problem from here. Let me say I do number 32. Okay, so I have coordinate P, coordinate Q, coordinate R. That's a triangle in space, right? Let me put the number. Now the factor normal to the plane containing these factors, these points, must be the cross product of two of those factors. Okay, let me choose factor PQ and factor PR. Give me a second. Make it smaller. Okay, factor PQ is 1, 2, 1, and PR is 5, 0, -2. So the cross product PQ cross PR, notice that they just want a factor, a non-zero factor normal to the plane, right? Okay, so you can use PR cross PQ or PQ cross PR. They will be opposite to each other, but for sure they are both orthogonal to the plane containing these three coordinates. 1, 2, 1, 5, 0, -2. I hope from this exercise set, you also see how important it is for you to be able to do the cross product fast. Okay, otherwise, it's pretty much behind, very, very, very behind. Okay, so the area of the triangle, PQR equals to 1/2 the area of the parallelogram, right? Okay, that's half of the area of this parallelogram. Let me show you this parallelogram here. Half of the area of that parallelogram. Okay, so that's half of the magnitude of the cross product. That's 1/2 times square root of 4 plus 49 plus 100. That is 1/2 square root of 153. I'll just leave it like that. Okay, because that number is a bit ugly, let me make sure I don't make miscomputation. Yeah, it seems like I'm okay. Oh, I make a mistake here. I make a mistake on the first one. It's supposed to be 4 here. It's supposed to be 4. Yeah, so it should be 16 here. So 1/2 square root of 165. Right? Okay. Now that's for number 30. Let's go on. Number 33 and 34, find the volume of parallelopipe determined by factors ABC. Remember, volume of parallelopipe is equal to the absolute value of a triple scalar product. Okay, the absolute value, because we want to make sure that it's positive. Okay, it's volume, right? Okay, so that's what we will do to find the volume of parallel pipe. I noticed that question number 35, 36 basically the same, except that in number 35, 36 we have coordinates. So what I will do is I will create vectors from this parallel pipe. Okay, so adjacent edges, let's say this is PQ, and then PR and PS, and the parallel pipe looks like this. Oops. Like that. Okay, so we use the factors, the adjacent factors. Let's say factor PQ will be -4 to 4. Factor PR is 2, 1, -2, and factor PS is -3, 4, 1. Am I right? Okay, so the volume is equals to the absolute of triple scalar product. I think our textbook also called that scalar triple product, either way. So this is the absolute of the determinant with these three factors here. Okay, which is, let's see, how do I compute this? So that will be -4 times this. That's 1 plus 8 minus 2 times. So I did this expansion here. It's -4 times this. Okay, my next one is this guy here, -2 times this guy. Okay, -2 times 2 minus 6, and then plus 4 times 8 minus -3. So that is -4 times 9, -36, plus 8 plus 44. What would 8? 16. Okay, that's the volume. That's for number 36. Number 38, let me move this up a little bit to save some space and then enlarge that. Use the scalar triple product to determine whether these points here lie in the same plane. I will not do it in full, I just give you the idea. So I have A, B. Then I will create AB, AC, and AD. Now we don't know if they are coplanar or not. What you will do is you do find the volume of that parallel pipe, and then if the volume equals to 0, then they are coplanar. In other words, they are all located on the same plane. Okay, now I will not do that in full. You do it similar to what we did in number 36. Okay, you find the volume of the parallel pipe. If the volume equals to 0, then they are coplanar. But again, the idea is like if you have coordinates in space, what you want to do is to find the factors that you can use as a tool to do further computations. Let's go on further. Number 43, I saw this question and I felt like, oh, you know what, that's quite interesting. Number 43, notice that I don't really do odd numbered question, right? We have a dot b equals to square root of 3 and a cross b equals to 1 to 2. Find the angle theta. Find angle theta. Now, so here's the thing though. We know that absolute of a dot b is equal to magnitude of a times magnitude of b cosine theta. That's square root of 3. Now, the magnitude of a cross b is magnitude of a times magnitude of b times sine theta, which is what we know here. You compute magnitude of square root of magnitude of a cross b will be square root of 1 plus 4 plus 4, square root of 9, which is 3. Okay, now what I will do is I will divide to get the tangent. So magnitude of a cross b over absolute of a dot b, that is equal to 3 over square root of 3. But at the same time, if you divide this sine over cosine, that gives us a tangent, right? Maybe it's easier for you to see if I do it this way instead. Give me a second. If I write the sine on the top of cosine, and then I divide. Notice that tangent theta equals to square root of 3, so theta equals to 60 degrees, right? Now, number 44, honestly, it's a hard question. Maybe not that hard, but let me show you why I want to go over that question. It's a very conceptual question, though. You don't really see that question in other place. Okay, so number 44A. 44A. Find all factors phi such that 1 to 1 cross phi equals to 3, 1, negative 5. Find phi such that okay, we start with let phi be factor ABC. Okay, so if I do the cross product, I j k of 1 to 1 ABC, I will get factor 2c minus b, and then a minus c, and b minus 2a. Now I will set this equal to 3, 1, negative 5. Notice that we have 3 variables ABC and 3 equations. So we have enough to solve the system. It forms a system of 3 by 3 equations. Okay, negative b plus 2c equals to 3, a minus c equals to 1, and then negative 2a plus b equals to negative 5. Okay, I happen to see that equation 1 minus equation 3, if I subtract that, 1 minus 3 give me 2a plus 2c. Actually, I add them, If I add them, negative 2a plus 2c equals to negative 2. If I multiply by negative 1, I get a minus c equals to 1. Now notice that this equation 4 is basically equals to equation 2, right? So we can do it this way. Then we will have multiple solutions here. Okay, we will get multiple solutions, but we can say that c is equals to a minus 1. So we say let a be the parameter, or you can also say let a be t. Let t equals to a. T equals to a. So c equals to t minus 1, and b will be negative 5 plus 2a, which is 2t minus 5. So factor v can be written as t to t minus 5 and then t minus 1. Okay, so any factors of this form will give you that kind of, the cross product will give us 3, 1, negative 5. Now that's for part A. Okay. Usually if we have a 3 by 3 system of equations, we have one unique solution, usually. But in this case, because they are not linearly independent, that's a term you will see in higher level. Basically, the linear combination of two equations give us the other one. If that's the case, then we have infinitely many solutions. Okay, and to do that, one thing we can do is use one variable as our parameter. Okay, now that brings us the next question in part B. In part B, number 44B, okay, show that there is no vector v such that 1 to 1 cross v give us 3, 1, 5. Okay, borrow from the previous part. Let v be ABC. So 1 to 1 cross ABC will give us negative b plus 2c, a minus c, b minus 2a. If I set this to 3, 1, 5, then we come up with this system of equations. Negative b plus 2c equals to 3, a minus c equals to 1, and then negative 2a plus b equals to 5. Now notice that if I add equation 1 by equation 3, I will come up with negative 2a plus 2c, which is 8. If I divide by negative 2, a minus c equals to negative 4. Okay? However, this is not what we have, contradiction to our equation 2 that says that a minus c is supposed to be 1. Okay? So, there is no such vector v. Okay? That's for number 44. Now, the next couple questions are very useful question for our future. But at the same time, I hope through these examples here, exercise here, we learn new stuff, how we use cross product, dot product, and so on and so forth in geometry. Okay, number 45. Let P be a point not on line L. Notice that in the next section 12.5, we will learn line and plane, right? Now suppose we have line L. This is line L. And point P, not line L. Show that the distance D from point P to line L, of course, it refers to the perpendicular distance, D, is given by the cross product of AB, the magnitude of the cross product divided by A, where is, QR is on the plane, on the line, this is Q, this is R, okay, and factor A is QR, that's factor A, and factor B is QP. Let me use different color. Let me use this color here. This is factor B. Show that the distance from point P to the line is the cross product of A and B divided by the length of A. Notice that this is basically doing the following. Notice that, let me write it down, the magnitude of A cross B is equal to the area of the parallelogram. The area of the parallelogram. Okay, now divided by the length of the base, which is factor A. Right? From geometry, we learned that the height of parallelogram equals to the area of the parallelogram divided by the length of the base. Or maybe to say it in a nicer way, that area of a parallelogram is equals to length times space. I'm sorry, length times height. In this case, the height is the distance we are looking for. Okay. Now that's just a technique though. In the next section, we will put more computation into this. Okay. The next question. Let point P not on the plane, and the plane contains PQR or QRS. So let's say we have a plane. And point P not on the plane. So we have QRS on the plane. Okay. And we want to find the distance from point P to the plane. We want to find this distance. Now the idea is we will find the triple scalar product, the QR cross QS cross what is other good color? The green one, maybe this one here. QP. Okay. Now notice that the triple scalar product, the absolute of triple scalar product, will give us the volume of the parallelepiped. Now, the cross product, the magnitude of the cross product, okay, let's call this A here, and this is B, and this is C here. Now, the magnitude of the cross product will give us the area of the base of that parallelepiped. Area of base. Now that gives us the height of that parallelepiped. In this case is the distance. Okay, I have one more question here. I honestly don't know why I want to go for this one, but it's about proofing, and you will see that one of the big weakness of my class is I don't do enough proofing. I don't ask proofing questions, but at least I hope through my supplemental video I can present to you more proofing. Okay, so along the way you learn to proof. We start with the magnitude of the cross product being squared. Now we know cross product, the magnitude of cross product is the same to the magnitude of A times magnitude of B times sine of the angle between them. Right? Now, because I square it, I will square this also. That gives us magnitude of A squared times magnitude of B squared sine squared theta, which I can rewrite as 1 minus cosine squared theta. Is that right? Now I will distribute this. I get magnitude of A squared times magnitude of B squared minus magnitude of A squared times magnitude of B squared cosine squared theta. Notice that the first term already matched with what we need to get. This term here is the same to this one, right? Okay, equals to magnitude of A times magnitude of B times cosine theta being squared. Now that's the one I will change into the dot product. Okay, that ends the proof. Okay, that's for this section 12.4.